Hi everyone, this is Mr. Lee. This is going to be a video on interaction diagrams. Interaction diagrams is a very helpful tool, very useful tool when we are utilizing forces for this unit and just physics in general. Um, yeah, so a couple of things about interaction diagrams. You'll never be asked a question directly about like an interaction diagram, so it can be like generalized, much like our sketches or our verbalizations. They can be generalized because you're not being graded on your ability to create interaction diagrams. But from your interaction diagrams, we'll be creating these things called free body diagrams, and those will be graded. So think about interaction diagrams like a stepping stone for you to be able to master the free body diagrams. All right, let's begin. So a couple of things about these interaction diagrams. You'll see through our couple of examples that the interaction diagrams are just there to show you how different things are interacting with each other. A very important note there you'll see on your screen, it says that not interacting through transitive property. So if you remember the transitive property, it's like the x is equal to y equals to z, therefore x equals z, right? And so I have one problem that explains that in a little bit more detail. But interaction diagrams only show how objects interact with each other, and not how one object can interact with another object by using another object. That's the transitive property. We'll get there. All right, so let's start off. The first one is a cat on a desk. So here we have a cat on a desk, and I'm going to show you how to draw a interaction diagram. So the first thing that you want to draw is to write the word cat, right? And just put a little circle around there. So that's our focus object, the cat. And now I want to, around the word cat, write all of the other things, objects, whatever that could be interacting with this cat, such as the desk slash surface. Okay, so I'm going to circle that. And because we're here on Earth, I'm going to also write the word Earth down as well. All right. Now, after this point, it's one of those things where if you have different color pens, it really does help show you what's actually interacting with each other. But here we go. So, is the Earth interacting with the cat? And you know what? I'm going to say yeah, it is. So I'm going to draw a arrow pointing to the Earth, and I'm going to draw another arrow pointing to the cat, right? Same line. And we will label this interaction. And this one is called the force of the earth, or the force of gravity. Okay. Now in the next video, I'll go over the notation for these different kinds of forces. But for now, we'll just call it the force of the earth. Okay. And the next one is the earth and the desk. Okay, so is the earth interacting with the desk? And yeah, the answer is yes. But because it's not interacting with the cat, I'm going to use a different color. And we're going to label this the force of the earth. Okay, so this different color shows me that these are two things that are interacting with each other, but it's not interacting with our main focus, which is the cat. All right, is the cat interacting with the desk slash surface? And the answer is yes. So I'm going to draw a line there, two arrowheads, and we're going to call that F of surface. And once again, in the next video, I'll go over exactly what we can use to label this surface force. But for now, we'll just call it F of surface. And there we go. That's our interaction diagram. There's nothing else there. And so we can see that from this interaction diagram, there's only two forces that's actually interacting with the cat. That's from the earth and the surface that the cat is resting on. Simple enough? Well, we'll see. Let's try the next one. Ooh, a falling ball. So, well, I'm going to do two scenarios here. Let's do a falling ball with air first. All right, so we'll call this scenario A. All right, so here we have the ball as my object. And because the ball is traveling through air, I'm going to write air there. And because we are here on Earth, I'm going to write the word Earth right here. All right. And I'm gonna do this as well. We have the hand. All right. Now, if you're thinking, Mr. Lee, why did you give that face? There's a reason why I'm being a little bit sneaky here. All right, so let's actually go through this. So, is the ball interacting with the air? And the answer is yes, because the ball is traveling through the air. The ball is interacting with the air, and we call this air force or the air resistance force. All right, cool. Is the Earth interacting with the ball? Oh yeah, it is. Oh yeah, we call that the force of the Earth. Okay, and because that force is directly interacting with the ball, we're going to be using black. Is the ball interacting with the hand, or is the hand interacting with the ball? And if you look at the picture, it's not. Yeah, caught me. That's why I had that funny face, right? Because if you look at the picture, the hand is no longer touching the ball, right? And so this interaction that I drew in red, right? If you drew that, I'm sorry, but we're about to erase it because the hand and the ball are not interacting. Whoa! So erase that. All right. Is the Earth interacting with the hand? Yes, it is. I'm going to do that in red. I'm going to call that the force of the Earth. Is the Earth interacting with the air? Oh yeah. Kind of hard to believe, but the air and the Earth interact. What is called that? The force of the Earth. The Earth interacts with everything. Let's see. Is the air interacting with the hand? Ooh, I could see an argument for yeah, but you know what? It's not interacting with the ball, so we're gonna leave that to red. So if you take a look here, right, there's a lot of different things in this diagram that are interacting with each other, but the only one we care about are the forces that are actually interacting with the ball. So that are two forces right there. All right, now let's do a similar one, but the ball is falling, but there is no air resistance. And I'm here to tell you, most of the problems that we solve will be with no air resistance. And so if there's no air resistance, we have the ball, we have the earth, and we have the hand. And so if you, it looks a lot like our other problem. And so I'm going to skip a couple of steps here. And the only force that is interacting with the ball is the force of the earth. Okay. And the hand, because it's not even touching the ball, right? It's very important. The hand and the ball are no longer interacting. So if there's no air resistance, so let's write that there, no air resistance. Because there's no air resistance, only one force is interacting with the ball, and that's the force of the earth. Okay, so another one. Ooh, okay, so here we have, let's say this is a bungee jumper. All right, so the reason why I had this here, let's write this bungee jumper. All right, so we have a bungee jumper here, and I'm going to have different scenarios just to show you the different kinds of forces that can be applied. So if you have anything elastic, such as a bungee cable, we call that the force of a spring, okay, or a force elastic. Both work. Most of the cases for our class, the only elastic object that we really use is a spring. So you'll probably see me, right, force the spring more often than not. Okay, so let's do a interaction diagram for this. And let's say there's no air resistance, right? No air resistance, no air resistance. Okay, so we have a person. It looks like the bungee cable is fully stretched. So here we have person, right? And the person's here on Earth. So the Earth should be the very first one you always draw. Because there's no air resistance, I'm not going to write the word air, but we do have the bungee cable. Bungee. All right. All right. So if I were to draw a interaction diagram, I would link the Earth and the person. We call that the force of the Earth. And the person is interacting with the bungee cable. We'll call that the force elastic, right? You can write the word spring if you would like. And let's do the objects that are not interacting with each other or with a person. So we have the earth and the bungee. So this is the force of the earth. Okay. And that is in a different color because it is not interacting with the person. So I'm going to highlight my two forces. Okay. So if I were to come up with our free body diagram, which is the next video, I'll make sure that only those two forces exist. All right. And let's say instead of a bungee cable, right? Instead of a bungee cable, we had, let's say, I don't know, like a string, rope, chain, all of these. So there's something unique about all three of these objects: string, rope, and chain. So these are objects that can only pull. Okay, and we'll see this in another scenario as well. But if you have objects that can only pull, which includes a bungee if you think about it, but the bungee is elastic, we call this the force of tension. Okay, and so if let's say the person was attached to like a string or a rope or a chain and not a bungee, very dangerous. We will write person instead of bungee. Let's write rope and earth. Okay, so the diagram looks almost identical, right? Almost identical, except the one force that is different is the force of the rope. We're going to call that the force of tension instead. All right. But if you take a look at it, the number of highlighted objects are the same. Next scenario where we're going to come back with this rope idea, but this time we are going to try to include many things together. So we have a person and they are pulling on a crate with a rope. All right, so I'm going to have two scenarios here. One is going to be with friction, and the second scenario is going to be without friction. So let's do the one with friction first. All right, so this is with friction. All right, with friction, no air resistance. All right, so here we have, oh, by the way, this is the problem. I'm going to start this one. This is what I mean by the transitive. This is the transitive property idea right here, all right, where you should not use a transitive property to create your interaction diagrams, and you'll see what I mean. All right, so the object here is a box, all right, and we have a rope, right, and we have a person. Oh, I forgot the very first one that we should always be drawing or writing in the earth, and well, the drawing is not the best, but yeah, there's a surface there, right? Otherwise, these two people will be hovering, or the person in the box will be hovering. All right, so we have a total of 5 different objects that could be interacting with each other. But remember, the only one that we care about is the forces that are interacting with the box. So get your pen ready. It's going to get a little bit messy here. There's going to be a lot of arrows. So first one, the earth and the box, right? That one's interacting, and we're going to call that the force of the earth. Okay. And while we're at it, I'm going to make the earth interact with a rope, different color, because it's not interacting with the box. The earth and the surface, right? Different color because it's not interacting with the box. And the earth and the person, all right, different color because it's not interacting with the box. Okay, now what about the rope? Is the rope interacting with the box? And the answer is yes. The rope and the box are interacting. And if you remember from the previous example, we call this the force of tension, or the force of the rope. All right, now what about the rope and the person? Is the rope and the person interacting? And the answer is yes. But remember, it should be a different color here because we only care about the forces that are interacting with the box. So I'm going to link these two, but have a different color. Okay. Yeah. What about the rope and the surface? Are the rope and the surface interacting? If you take a look at the picture, the answer is no, because the rope's not on the floor. Okay. What about the person? All right, so is the person interacting with the box? And the answer, and this is what I mean by the transitive property, the answer is no. The person is not interacting with the box. The person is not touching the box. Whoa! And you might be thinking to yourself, well, yeah, well, technically. And so that's where you're gonna get in trouble if you're thinking to yourself, well, technically. So the answer is no. The person is not interacting with the box. Okay. The person, however, is interacting with the rope, and we indicated that there. Is the person interacting with the surface? Oh yeah, the person is interacting with the surface, right? Because the person is on the surface. So we're gonna write that right there. Okay, and we'll call this F the surface. And once again, in the next video, I'll go over the specific notation for the surface force. Is the person interacting with the Earth? And the answer is yes. We already have that arrow linking, and I think yeah, that's it, right? All right, cool. And what about the box and the surface? Is the box interacting with the surface? And the answer is yes, because the box is on the surface. And we'll call that F of the surface. All right, so with all of this, we can see that there's only three objects that's interacting with the box. That is the rope, that is the earth, and that is the surface. Okay? Very important that you see that the person is not interacting with the box. Okay, so there's friction here. So you might be thinking, all right, Mr. Lee, well, where's this frictional force? I'm here to tell you that if there is friction, okay, whenever you have surface, write a little note there that friction exists. Friction exists right there. And so not only is there a surface force, but there is also a force of friction. Okay, so because we added another force, I'm going to do this in a different color so that you can actually see it. There are a total of 3 objects that is interacting with the box, but there are a total of 4 forces. Let's list them. The 3 objects are the rope is interacting with the box, and with the rope we have the force of tension. We have the earth that's interacting with the box, and we call that the force of the earth. We have the surface that's interacting with the box, and with the surface, there's 2 forces that exist. One is the force of the surface, and the other one is the force of friction. All right, so let's count them. We have a total of 4 forces. 1, 2, 3, and 4. Okay, total of 3 objects, but 4 forces. All right, so in the second scenario, it says, well, what if there wasn't any friction? So if there wasn't any friction, you would include just the tension force, the earth force, and the surface force. All right, so that's the interaction diagrams. And in the next video, I'll go over what we can do with these interaction diagrams. Okay, so this is the next step after you complete your interaction diagrams. I'll see you next time. Bye-bye.